Welcome, Algebra 1 students. I miss seeing your bright and shiny faces. This is Miss Jero, for those of you that don't have me. A variety of us are going to do some videos, but here's the video for day 1. Hopefully you have the notes and you've printed out the notes, or you can watch it on this video. But I'm going to go through the notes. You can fill them in as you go. We'll also have a filled out copy there as well for you. But we're talking about quadratics today, and we're talking about which are only of degree 2. And so that's the key thing that you need to know, is that polynomials are only of degree 2, right? That's your x squared, and every single one of them is going to have an x squared in it. If it doesn't have an x squared, it's not a quadratic, and we're not what we're talking about. We're only talking about quadratics. So let's talk about what picture looks like. And here is the graph of example 1. So you'll notice that we have all of these tables. We just took these points and we plotted these points. And you'll notice it's not necessarily an XY axis because you don't see them, but it is physically every single point that's on here. And you'll notice that it makes a U-shaped graph. That's the thing that's a parabola. It always makes a U-shaped graph. And so you'll see that every single time, and it's called a parabola. U-shaped. And I'm going to type the next word because it's easier. And you see this on your other paper too. But there are some key features on this U-shaped graph that we're going to talk about. And the first one's called the vertex. And the vertex is key because the vertex is where the graph changes direction. And so if you look on this graph, you'll see at the very bottom of this graph is right here. And this is called the vertex. And so the vertex is an ordered pair. And this is the vertex right here. So when we write a vertex, we're going to write it as an ordered pair. So I would write it as 20, comma, negative 9. Sorry. You're always going to write a vertex as an ordered pair. It's always where it changes direction. So it's the bottom of the graph or the top if it's upside down. So that's the first thing we're going to talk about. We're also going to talk about, in this, you'll notice there's a green dotted line. And this green dotted line is a vertical line that I could fold the graph on, and you'll notice it matches. And this vertical line is called the axis of symmetry. And I'm going to put a little arrow, and I'm going to use green so you can tell. But this green line right here is actually called the axis of symmetry. And here's the key thing about the axis of symmetry. And the ones that we're going to be doing, they're always equations. And in axis of symmetry, they're always equations. But it's always going to be an x equals. You're always going to write it as the x equals. And it's always the y value, the x value of the vertex. And so it's going to be x equals 9, or x equals 20, x equals 20, because that's the line that I folded on. Remember, vertical lines are x equals. So it always goes through the vertex. So the axis of symmetry and the vertex are related. And you'll notice that negative 9 is the only number that didn't repeat on my graph. On my y values, it was the only number that didn't repeat. And so that's a nice key feature about the vertex as well. And then we're going to talk about the x-intercepts. And if you remember what x-intercepts are where the graph crosses the x-axis. And so I have my x-axis sitting right here in black. And you'll notice that I have two x-intercepts. I have an x-intercept right here, and I have an x-intercept right here. And if you remember, x-intercepts, again, are where the graph crosses the x-axis, and they always have the y value is 0. And so in our case, and again, intercepts are always written as ordered pairs, so I have 17, 0, and I have 23, 0. Now, 90, we always have two ordered pairs. That for x-intercepts, there's always going to be two of them on a parabola. If it crosses the x-axis, it's going to have two, unless it bounces, right? Unless the vertex is sitting on there. But in general, you're going to have two because it's an x squared, so there's two x-intercepts. So that's one of the things to remember as well. If you remember about x-intercepts, you can also call those zeros. And if they're called zeros, you just have to write the numbers. You don't have to write x equals or either way, but they're the x-intercepts. They're also zeros, and x-intercepts are the same things. Ooh, hey, stop moving. Sorry, I started talking to my computer. X-intercepts and zeros are the ones that, the zeros and x-intercepts is exactly the same thing. But x-intercepts have to be written as ordered pairs. So let's talk about domain. Domain, remember, domain are the x values. And domain for every single parabola that we're going to do is all x values. So it's all real numbers. And I'm going to make this smaller because I've now run into paper. It is all real numbers. And for every single domain for all of these parabolas, it's always going to be all real numbers. That's an easy way to remember it. That would be the negative infinity to infinity piece. We've talked about that as well, but it is all real numbers. The range. So the range is the y values, if you remember. Now the range, the lowest y, this has a low y value. And you'll notice that this graph does keep going. It's actually missing. I should put the arrows on there because it is actually missing its arrows. But it should have arrows on the ends because this graph does keep going up. So this range has a lowest number. And again, that vertex is key because that vertex is talking about that range again. It deals with the range as well. So the range starts at that lowest, at that the y value. So y is greater than or equal to -9. You could also write it as bracket, oh, wrong bracket, bracket -9, comma, and I don't have the way to write infinity, the symbol for infinity, so I guess I could just write the symbol for infinity. Here's my infinity symbol. Here we go, look at that, parentheses. There's my range. Again, we can write it either way. If I'm talking about, now let's talk about some other things that we can talk about for this graph, because today is all about graphs and vocabulary. There's a minimum y value, and I'm going to make this smaller again. There is a minimum y value, and again, that vertex is coming into play. That vertex is used all over the place. The minimum y value is -9. Because it comes from, that's the vertex. That vertex, we love that vertex. It's used all over the place. That vertex is used all over the place. So the minimum y value is -9. Oh, hey. Sorry, there we go. And the maximum y value, well, this graph keeps going on and on forever. So does it have one? Nope. It's got a maximum y value of none. Okay, so this is a graph that's not sitting on near the origin, and that's totally fine. It doesn't have to sit near the origin. It's a parabola. Now, are there equations for this graph? Yes, and we're going to talk about equations for this graph. They're written in 3 different ways, and I want to show you all 3 ways. So you'll notice you can have, this is the filled in notes of the piece that you had, so you can see that. Here are the 3 different ways that you could have them written. Okay, and you'll notice that I have what's called the vertex form, and that just means you see the vertex. Oh, look, there's the vertex sitting right there. You have the standard form, which is y equals ax squared plus bx plus c. Remember that? We've usually write it in that way. Ax squared, squared plus bx plus c, because I don't want to do my, I could do this. Yeah, whatever. Yeah. And then your intercept form. Intercept meaning that you've solved, right? You've got your x-intercepts. But when we say intercept form, we literally mean your x-intercepts. You'll notice that these are your x-intercepts. And we'll talk more about that in the coming weeks. But I want you to recognize that that's your x-intercept. All right, so here we go. Let's do another example. So I have this second example here, and again, I've got a bunch of points, and here's my graph. And you'll notice that this graph is slightly different because this graph is now upside down. It means it opens down. Okay, that's some vocabulary that we use. We talk about it opening up or opening down. This one's opening down. Okay, and you'll see why when we talk about the equations for this graph. But again, the first thing that I want to talk about is I want to talk about the vertex. So I'm going to, and this is what I want you to do, I want you to put a dot at the vertex. Okay, there's a dot at the vertex. I want you to put an arrow, and I want you to label the vertex. Okay, and so again, I'm going to label the vertex. It's the vertex. And when I label the vertex, I'm going to write vertex, and I'm going to write the order pair. Because the vertex, by definition, is the order pair. So I've labeled the vertex. Again, this is a parabola. I want to talk about the axis of symmetry. And the axis of symmetry, again, I'm going to draw an arrow to the axis of symmetry. I'll do it in a different color. Actually, I'm going to do this one in blue, and this in blue, the vertex in blue, and then I'm going to do the axis of symmetry in green. And you'll notice, ladies and gentlemen, again, the axis of symmetry goes right through that vertex. It is related to that vertex. It is an equation. And we're going to call it, it's always x equals. And so in this case, it's x equals 1. So again, we're labeling that the axis of symmetry. We're going to write the equation that is x equals 1. And now we're going to talk about x-intercepts. And so I'm going to use my highlighter. And so I want you to do this. I want you to take your pen and I want you to highlight your x-intercepts. And I want you to write beside x-intercepts and tell me what they are. And so for those of you, a reminder, here they are in red. And we're going to write it over here. So I have x-intercepts. And again, intercepts have to be written as order pairs. So x-intercept is -1, 0, and 3, 0. I'm also, since I've already talked about x-intercepts, I'm going to talk about zeros. And as zeros, do you have to write them as order pairs? No. Zeros, you can just write x equals -1 and 3, because again, they're the same thing as the x-intercepts. Well, there is one on here that we haven't talked about yet, and that would be because we didn't have one on the other one, but I have one here, and it's the y-intercept. And I'm going to take my pen and I'm going to do it in yellow so you can see it in yellow. And again, a y-intercept, if you remember the y-intercepts have to have the x value being 0. So the y-intercept, and not all the graphs will have one, you just may not see it on the graph. We didn't see it on our other graph, that's why we didn't ask you to find it for us. There was one, but it just couldn't see it. And so the y-intercept was 6, 0, and you can see that on this graph because I have a 0. I'm sorry, 0, 6, not 6, 0. 0, 6. And so you can see it on your graph, and so I'm going to label it as the y-intercept. I'm going to talk about the domain and range again. We're going to talk, it's vocabulary heavy. Domain, again, for every parabola, even we forgot to put, I'll bet you I forgot to put arrows on this graph again. Yep. Even when we forget to put our arrows, because we forgot to, but we're talking about these graphs keep going on and on and on. And so domain is, again, the x values. And these x values, I can use every single x value there is. So my domain is all real numbers. And again, you could write it as, let's see if Miss Giro can do it. Hold on, I'm going to write range, and then I'll come back in my pencil and write domain. And you could write it as -infinity to infinity. Ooh. That's Miss Giro with pen. But okay, so let's talk about the range. Now the range for this one doesn't start at the bottom and go to the top. It doesn't have a lowest. It does have a highest, which means I stop up here. We always go from bottom to top. But in this case, the bottom isn't my starting point. My top is, it doesn't start and then has no end at the top. This starts at the bottom and ends at the top. So when I talk about the range, I'm talking about I've got a highest point, which means my range says y is less than or equal to my highest y value, which is at the vertex again. That vertex comes back into play, that vertex right there. And so y is less than or equal to 8. Or, as I like to write it, I'm going to, oops, hit the wrong thing. Sorry about that. Pins. I could write this from -infinity, comma, and here's my 8. Ooh, and that gets a bracket. Let me see if I can fix this other one, because that looks like an 8 to me. So I'm going to fix that. Comma. There we go. So again, -infinity to 8. If I want to write it, I'm just going to write it so you guys can see it. -infinity, although you write the symbol, and then 8 with a bracket, is the range. Again, because I have that. And so when we're talking about minimum values, minimum y values, that means the lowest y value. Well, there is none because this graph keeps going down. I have a maximum y value. In that case, it will, again, the vertex, go back to that vertex. Vertex is like the end-all be-all of a lot of things, and that vertex, the highest y value is 8. Oops, I typed 9. 8. So I have the maximum y value as 8. And so, all right, so we have our minimum, we have our maximum y value, we have our domain and range, and you'll notice I'm going to go to the next slide so that you can actually see. Again, that's all the filled in stuff. Oops. But I wanted to scroll down so that you can actually see vertex form. Again, we just have to see it. We'll talk about more of it at another time, but there's your vertex. You can see the standard form. It's got a negative. That -2 is what makes this thing go upside down. And again, intercept form has the 2 x-intercepts. Again, here's your x-intercepts. And we'll talk about how to do this in a later date. Right now, you just need to recognize that these are all the same equation. They just look very different. That's what we want you to recognize for these. All right, so now let's talk about the third one. And so the third example that we have is x squared. And so it is the generic one. It's what we call the parent graph. Like y equals x is a parent graph. So here's a generic one. And we didn't start with this one because we want to make sure you recognize where all your x-intercepts and y-intercepts. And for this one, some things are the same. And so we wanted you to recognize that. And you'll notice x squared is x times x. So -2 times -2 is +4. And -3 times -3 is +9. So that's where all those are coming from. But again, we're going to label. So I'm going to start off with what I started off with before, which is the vertex. So we're going to label the vertex. So I took my pen and I'm putting a dot at that vertex. The vertex is sitting right there. And I'm going to go off to the side and I'm going to label this. And I'm going to call this the vertex because it is. And the vertex here is 0, 0. That's really nice of it. And so now I'm going to talk about my axis symmetry. And it's not, well, this one you cannot see. So I'm going to draw it in so you can see it. And I'm going to draw it as a dotted line. And again, it goes through the vertex. And so if it goes through the vertex, it's a vertical line, always through the vertex. Oops. Axis of symmetry. I'm going to abbreviate. And again, it's an equation. It's always x equals. And in this case, through the vertex, the x value of the vertex is 0, so it's x equals 0. And so now we're going to, again, label other things. So I've got to label my x-intercept. So I'm going to write over here, x-intercept. Okay, and so for my x-intercepts, I'm going to take my handy-dandy pen and I'm going to go red. And, oh, wait! There's only one because this graph does what we call bouncing. So it's going to bounce off the graph. It still is the x-intercept, but it's just called a double root. You just need to know that where is it? It says again at 0, 0. There's my x-intercept. And now we're going to talk about doing my y-intercept. Oh, you know what we should do with that? We should also do the zeros. And you can't see that, so let me move this. So the zeros, right? So the zeros, and again, the zeros for this are just literally the zeros. So you can write x equals 0. You can just write 0 because it's always the x values. So I got that. All right, let's talk about the y-intercepts. There's always only one y-intercept, and it's 0 comma something. Oh, wait, so let's look, and I'm going to use my yellow. Oh, wait, it's the exact same thing. And because it bounces off that x-axis, it's the exact same thing as the x-intercept. Or the y-intercept, because they're 0, 0. So I've done my x-intercept, my y-intercept, my zeros. Oh, we should do domain and range. And domain, again, domain is the exact same thing for every single parabola that we do. Domain is not changing. So the domain for this is all real numbers. every single time. It is all real numbers for domain. Let's talk about the range. So this graph opens up. And because this graph opens up, I'm going to start. It's going to be y is greater than or equal to, because this graph opens up. What is the lowest y value? Again, going back to the vertex, what's the lowest y value on the vertex? And in this case, it's going to be 0, so it's y is greater than or equal to 0. Or you can write it as, bracket 0, comma, infinity with the symbol for infinity. I just can't draw. I'm not going to draw it right at this moment. And so let's talk about the min y value, meaning what's the lowest y value that there is for this graph. That's 0, again, vertex. What's the max y value? And there's none, because this graph doesn't end. Again, this graph has arrows on the ends, and again, I'm missing my arrows. Sorry about that. Let me put my arrows on. This graph has arrows on the end, so this graph doesn't technically end. It just keeps going and going and going. And so again, I'm going to show you that we have all of these. There we go. Yeah, Miss Jarrett's just hitting the wrong things. Sorry about that. There are no other forms for this graph because there's no other way for me to write x squared. X squared is the only way for me to write it. And so a couple things. What if I want y equals 3x squared when x equals -7? And I'm going to actually do this. Can I do? It won't let me do that. Okay. I'm going to do this. I'm going to use a box. Oh, please. Because I don't like the way that I wrote that, so I'm just going to fill. Let's do this first. Oh, please. Okay. So find the value of the quadratic expression 3x squared when x equals -7. That literally means that I'm going to write 3 and a parentheses where the x was, and I'm going to put my squared, and then I'm going to put my -7 in that parentheses. And -7's quantity squared is -7 times -7. Those parentheses make a difference, which makes this 3 times 49. And 3 times 49, again, you can have a calculator out to help you on that. But 3 times 49 is 147. So what that means is that if you were to plug in -7, you would get out 147. And if you were to, and that would mean when you graph x equals -7 on the x-axis, you go all the way up to 147. What about if you had the quadratic expression x squared plus 4x minus 21 when you have -7? We are going to do literally the exact same thing. And so I'm going to write, again, I'm going to put parentheses where the x was, put my square, plus, I'm going to write the 4 in the parentheses. And we've done this stuff a lot, just not in terms of writing and saying and finding the value of the quadratic expression. But again, and then I'm going to plug in -7. And again, you can use your calculator to help you out with this. You can use Desmos because you all have access to Desmos, so you can use Desmos to help you out with this. And now I'm actually going to type because I can type now. It's going to be 49 minus 28 minus 21 because 7 times 4 is 28. And so when you do that, you actually get out 0. Which means, ladies and gentlemen, when you plug in -7, you get out 0. That means that -7 is an x-intercept. That is what that means. And -7 is an x-intercept, just an FYI. Okay, in our third example, we have find the value of the quadratic expression 3x squared plus 4x minus 5 when x equals -7. So again, I'm going to do the same exact thing. I'm going to put parentheses. I'm going to put the 3 and then the parentheses. And then the squared, so I'm putting parentheses where the x was, minus 4, parentheses, and then the minus 5. And in those parentheses is going to go to the -7. And again, a reminder that -7 times -7 is not -49. Parentheses make a very big difference here. If you do not put the parentheses when you put it in the calculator, you are going to get it wrong. So just an FYI, that is really important. If you just do -7 squared without a parentheses, it will give you the incorrect answer because you put it in wrong. 7 times -7 times -7, that's a positive 48 minus 25. And 3 times 49 minus 28 plus 5. And so I have 147 plus 28, or plus 23, because I did 28 minus 5, which does give you 170. And so the answer key actually has that as not 170. It has it as 180 maybe? Hold on. But they put a +5 instead of a -5. They have it was 180. It's 170, not 180. So just an FYI, because it's still a -5. That -5 doesn't change spaces. So, all right. So let's talk about the last one. A couple things that you know. You will have MathSpace for homework. So you do need to go onto MathSpace and do your homework. So there are 2 things that you need to complete. After this video. Number 1 is the Google form about the video. See Blackboard or Google Classroom to complete this. And the next one is MathSpace 8.01. And this is due on Monday. Just an FYI. It's when it's going to get shut down. It's not going to get extended. You have until Monday to do that. So 2 things to complete after this video so that we know you've done the video, and then you have MathSpace, and the MathSpace is due on Monday. You can open and do whenever you want to. We will be available for office hours. We'll post those both on Blackboard and on Collaborate and a Google Classroom, so you have both of them. But I hope you have a very good day, and we miss you and cannot wait to see you.